And it's...
Thank you, Jarek.
You can start.
Okay, so hi everyone. Glad to see you on our talk. Welcome on the second day of the MCE. This year we have a positive tech motto, and actually there are plenty of meanings of these words. And our understanding of these words is just to care about your application size. From our point of view, it's something that it's the first experience your users have with your app. Just before they see the very first stunning screen, you probably don't want to ask them to download dozens of megabytes from the Google Play or iTunes or App Store, sorry. My name is Mateusz, and this is Jacek, as Jarek already introduced us, and we are here to share some thoughts around the topic with you. And we did our best to make this presentation as practical as it could only be. So we'll be talking about the real app, which you can actually download from the Google Play right now. And this is Eco, the official mobile banking and payment app for PKO Bank Polski. And along with our team, we've been working on it for more than 2 years right now. And we reached 1 million of active users quite recently, and 20% of those users are still using Android 4, whichever version of Android 4, so we have to support Min SDK at level 14. Our app is quite big. It consists of around 200 different unique screens, I mean activities, fragments, layouts, and around a year ago, we had a moment when our app just grew up to 62 megabytes, and that was the moment when we started internally. We started thinking what we are doing wrong with that, and maybe there are some things we could improve to slim it down. And so let's move back a year ago, and Jacek will analyze the current state.
All right, so a year ago, we were here and 62 megabytes, so we had to do something about this. So first off, we decided to use the built-in Android Studio tool called the APK Analyzer, which is a great tool, and this is what we got. So we got 62 megabytes raw file size and 58 megabytes of download size. At first, we kind of didn't know what these sizes exactly mean and which one is more important. So we first had to learn exactly what we're trying to optimize. So they're both important, and there are separate ways. So first of all, just to explain, whenever you push your application to Google Play Store for the first time, this is the size that we call the raw APK size. And then when your users actually try to download this APK, it's not the same size because, oh, my mic, is it working? All right, sorry. That's not the same size because it gets compressed by Google Play. So we actually end up with something called download size. But then, after it's being downloaded by the users, it goes back to this raw APK size, let's say, and actually after installing, some parts of it get uncompressed, and we're ended up with something called install size, which is even bigger than the raw size. And then there's a similar relation between download size and so-called update size. So whenever you push your update to Google Play, it doesn't force your users to actually download the whole app again. It just makes them download a binary diff between two versions. So it's normally a lot smaller. So just whenever you go to for instance, the Google Play app on your phone, and you can see those screens. Whenever you try to download an app or update an app, you see these numbers in the same spot. So these are numbers that we're talking about here. It might be a good question for your own app, as a developer, how can you estimate these numbers? What the update size is going to be, what download size is going to be. So there's a tool called the APK patch size estimator. And we actually run it for our own app here. And as you can see, there's a diff between two versions, and all of these numbers. So we've got we've got the raw size here, download size, and update size. And these numbers should be quite accurate. They might be not 100% on, but still very good estimate of what these numbers are going to be for your application. So now as we know what these numbers are and what should we be focusing on, we can go back to this screen. And as you can see, we're still at 62 megabytes here because we didn't do anything yet. And we have 50 megabytes of resources, which was, well, we kind of suspected at first that we probably have a lot of images, but it was surprising as well because, well, there is APT, right? And it has a built-in cruncher, so it should do something for, for us and just maybe optimize some of these images. So we kind of like knew that there probably would be some problems, but we didn't know why we still had like 50 megs and why APT didn't work that well for us. So actually we had to just go deeper and just try to understand how APT works and what it does to our images. So first off, what APT does when it scans through images, it's trying to figure out if you're using like only grayscale maybe or just all colors. And then it does the same for the alpha channel. So if your images have like some kind of transparency, it tries to detect it. So for instance, we have an example here. So this is like a standard image, let's say. We exported it from Photoshop. And let's see like the data about this image. So it's 254 kilobytes on disk. And as you can see, the color space is RGB. And there is alpha channel, which is kind of surprising because this image doesn't have a lot of transparency. And there is not too many colors there. So let's see what APT can do with this image. So it seems like it can do a lot, actually. After processing through APT, we're getting 131 kilobytes, so it's a lot less. And there is no alpha channel, and there is only grayscale. So it actually is very good at detecting these things. So just use this if you're using alpha channel or not, and if you're using colors or not. So that's the two things that APT does. And actually does one more thing, which is, And so we're getting here like 48% reduction for free. You don't have to do anything. It's enabled by default. So whenever you have a case like that, it's going to help you out a lot. Now we have the third one, the third optimization. So it's actually the most advanced technique. So what APT is trying to do here is trying to detect if your image has 256 colors or less. So if it does, then it can actually transform it to a more efficient format for PNGs. And then it would decrease the size of the image like significantly. So we have another example here. And this is an actual image from our application. And as you can see, it has like over 2K colors here. So it's quite a lot. And let's see what APT would do to this image here. So yeah, the data for this image is like 123 kilobytes here, and RGB and alpha channel. As you can see, this image has transparency actually, so that probably couldn't be cut out by APT. And it has some colors as well, because these iris are blue. So yeah, let's run it through APT, through a cruncher. And now we're ended up with still 123 kilobytes on disk, and same color space, same alpha channel. So it seems like, well, the only thing that actually changed is these numbers, which is like some metadata, but it actually doesn't, it doesn't like change the actual size of this image. So actually in this case, APT didn't do anything for us, since this image had 2K colors. So in this particular case, we're getting 0% improvement by running APT on it. So just to sum up for like our application, we ran it like, let's say mid-2016. And at that point, we had 53 megabytes of resources in our Git repository. And after we ran it on this, we've got an APK, which we later on uncompressed to get these resources out. And then we got this number, which is 50.3. So it's about 5% reduction for free. It's still great that we don't have to do anything, actually, to get this improvement. However, let's go back here for a second. And let's think of what could happen if we could actually compress this image or transform it into an image that has 256 colors or less. So on the left side, you can see it's the same image we had before. And then it got transformed. And it got transformed the way that well, the quality got reduced, yeah, but in the means that we reduced the number of colors. And then we have this image on the right side, which has like 251 colors. In terms of visual difference, there is almost none. As you can see, like it's very similar. However, in terms of size, there is a significant difference. So here we have 123 kilobytes on the left side, and we have 57 kilobytes on the right side. So it's a huge difference between these two images here. And this is the problem with APT. Since it involves lossy compression, and we had to kind of like lose some quality during this compression, even though we can't actually see it here, this is what APT just can't do. So that's why there are some particular things that we have to do ourselves in order to help out, the Android build system to optimize our assets. So I'm going to hand over to Mateusz now to tell you more about our large graphics and how we dealt with them.
Oh, sorry. Okay, so since we know where we are, we can talk a little bit about graphics. And by graphics, I mean all the large images we probably all have in our apps. And basically, we have 5 different formats supported natively by Android platform. It's PNG, it's JPEG, it's WebP, it's BMP, and GIF. And since we are focused on non-animated and efficient formats, let's take the first 3. So starting with PNG, PNG is a lossless compression algorithm, which is especially, as Jacek previously said, is especially efficient when we can encode the PNG in a so-called palette mode or indexed color mode. And this can be done only when your image has no more than 256 colors. For us, it usually means that we needed to reduce the quality of our images to transform them into the palette PNGs. And there are actually a lot of tools in the market which do that, or add some other optimizations. We took one. It's the PNG Quant. It's a lossy PNG compressor, which is actually a very efficient way of generating the palette. And we combine it with Zopli, which is a lossless compression algorithm made by Google, and it's dedicated for PNGs and XZIP. And it actually improves PNG Quant results a little bit, but unfortunately it's quite slow as well. But we took it. So let's take an example how this stuff works. So we have an image from our app. It has a alpha channel. It's more than half a meg, so it's quite a huge file. It has a lot of colors, nearly 65K of colors. And if we try to run Zopli on it, you can't see any visual difference because, as I said, Zopli is a lossless compression. And we can reduce the size of this image by nearly 20%. But when PNG Quant comes into the game, it changes a lot because we can reduce the number of colors to 256 colors, and we can reduce the size of the image by almost 80%. When we combine together PNG and Zopli, we end up with exactly 80% reduction. So our final image is only the 20% of the previous image, of the input image, without any visual difference. I hope on the screen you can't see any visual difference between them, but the difference in size is huge. So to see actually how these images are compressed and how PNG algorithm works here, we can turn them into the so-called thermal mode. It's the output of the PNG thermal program, which just shows you how well the PNG algorithm works here and how well the image is compressed itself. And on the left upper side, you can see the input image, which generally is quite okay. The blue areas means that image is well compressed, while on the opposite, the red areas, orange, yellow, means that it's not so good. And especially around those banknotes which are rolling out from the phone, it's not well compressed. On the opposite, we have Zopli and PNG Quant, which has a lot of much less red and orange colors, and that's the way it works. So what if our image actually will land into a component like this? We call it teaser, and it's just a dialog which just always have a white background. So maybe we can do some further optimization with the image. For instance, removing the alpha channel because it always will be white. So the first thing was just to maybe convert it to the JPEG. And as you know, probably, JPEG is a lossy compression and lossy encoder, and there are a lot of tools which can do that. First, we pick up Convert, which is a part of the ImageMagick package. But we eventually end up with Getsly, which was introduced by Google, and they announced it around 2 months ago, their research blog. And it generally does the same for JPEG, what Zopli does for PNGs. And we found out that it's around 20% better than Convert. So so we took that to convert our images to JPEGs. But always with JPEGs, there is always the same problem, like which compression level you want to choose and how much quality you can sacrifice to gain the benefit of size reduction of the file. So we took a Butter Ugly I'm sorry if I pronounce it not correctly. We had some conflict with Jacek around that, but maybe some of you know how to pronounce it. Before&after is it's a tool which is very simple from the user point of view, because you just have to pass 2 images, and it returns a score of psychovisual similarity between those 2 images. And that is a perfect way to find the appropriate compression level in terms of the quality and the size. So we just, so let's take our first PNG, more than half a meg, and do a binary search for the compression level on this JPEG with the before&after score at 2.0. We found that this value fits the best for us. Like, we can accept the visual difference when it's at this score, and we end up with a JPEG which has a little bit more than 100K, and the quality of the JPEG is at around 90. Yeah. Comparing it to our previous example, the optimized by PNG and Zofli, we gain another benefit, but it's not so huge, but still we have. So you might take it into account. So that's not the end. We have a WebP format. Some of you might be very surprised that we have such a format supported by Android. This format was introduced by Google in around 2010, I guess, and it was invented as a format of very efficient encoding images for web. It also has a for movies variant, and it's natively supported by Android, actually, but in 2 flavors. So the first flavor is available from Android 14 and above, and it's basically a lossy compression algorithm, and it doesn't support transparent images. And we found out that it's better than JPEG. How better, we will see in a sec. And there is a second flavor, which is available since API 18 and above. This is a lossless compression and supports transparency. And we did some internal checks here. It worked better than PNGs generally, but unfortunately, due to our mean SDK support, we didn't go that way. So we took the first flavor. So having our PNG more than half a meg and running a web lossy here, again, without any significant visual difference, of course, without the alpha channel, we end up with an image which has a quality at 80% and only 61K. So that's a huge difference, actually. And comparing it to our Gatsby, yeah, it's almost twice smaller. So having our app in mid-2016, APK size at around 62 megabytes, and applying all those tricks to our APK, we end up with a result of 31 megabytes. So it was a 50% reduction of the APK size. So quite an amazing result for that moment. And but that was not the end. The second thing we did was to look at the densities. So we all know that Android platform supports different screen densities, and we have dedicated folder for different graphics, for different densities, and we started with analyzing our user base, what their devices are, and we came to the conclusion that we can just, without any hesitation, just drop out MDPI, because nobody used that devices, and we end up with those four densities. The next thing was to actually, our thought just came to our mind, was to maybe, we ask ourselves, do we really, all those PNGs, do we really need to have them in different densities? Maybe Android can do something for us. Like we already knew that that Android just scales down graphics or app if it doesn't have the one for appropriate density. So maybe we can just leave only the highest one and let the Android do its job, and then reduce the APK size by this way. So here is an example of a screen from the app. This is, let's focus on this icon in the red square. This is the icon which is provided exactly for the HDPI density, and you can see that it renders quite correctly on such a low density, while on the other side we have a version from the XXX HDPI, and the Android platform just took it and downsized it for the HDPI density. And I hope you can see that there are some, oops, sorry. Problem. Okay, I hope you can see on the screen that there are some glitches here and there on this logo in this icon. And since this particular icon size isn't so huge, we didn't want to sacrifice the quality of this particular screen because it's actually quite popular in the app. So we just left this particular icon. We left for all densities. But on the other hand, there are some places in the app which are not so popular, like this one. This is the onboarding screen where usually user sees only once, and there is a screenshot of the app itself with some label under the screenshot. We have to provide, because our app is supports 2 different languages, we have to provide 2 different screenshots. So maybe we can do something with those graphics, which are way bigger actually than those previous icon. And again, on the left-hand side we have HDPI. On the right-hand side we have XXX HDPI. There are some glitches as well, especially at the top of this phone, but you know that we started thinking maybe there are some graphics which we are okay with removing them, and yeah, so we went that way, and having APK at 31 megabytes. And removing all MDPI graphics and leaving only the XXX version for some of them just took us to the result of 22 megs. And that was another 30% of reduction. And this was actually quite an engaging story, so we didn't end up with that. And now Jacek will tell you a little bit about what we did with icons.
All right, so regarding icons, we first considered switching to vector drawables, which, well, natively is supported from API level 21 plus. So since we didn't have that, we couldn't use this support. But fortunately, there are other ways of supporting it. So first of all, there is this so-called Gradle way, which basically means that during compilation process, when you have your vector drawables stored as XMLs, the Android build toolchain is actually generating PNGs for you. And it's putting it back to the APK. So of course, there are some upsides of that. So first of all, you don't have to manage all these PNGs by yourself, so that's great. But since they're being put back into the APK, it doesn't really do too much for us in our case, since it doesn't reduce the size of the APK too much. So fortunately, there is another way as well. So this is the support way, which basically means that vectors just at some point became a part of a support library. So that was great, and we got this class, VECTORDRAWABLECOMPAT. So as a part of vector drawable support, whenever you just need to put this line to your build Gradle config file, and you're good to go, regardless of your API pretty much. So yeah, we did that, and then there was a problem. Okay, we have a bunch of PNG icons all over the place. We want to convert to vector drawables. So how do we do that? So yeah, that's our problem. On the left side, you can see that's one of our icons that we had, and it's a PNG file. On the right side, that's the Android vector drawable format. Well, unfortunately, there is no easy way to convert it directly from left to right, but there are some steps that you have to take in between, and so I'm going to tell you about them. So first of all, if your icon on the left side, if your image is stored as a Adobe Illustrator format or some other format that you can open in your graphics editor and export as SVG, that is great, and you're done with that part. Unfortunately, sometimes you're gonna have PNGs or JPEGs or other assets, and we're gonna show you a tool in a second that's gonna help you out with that situation. Then when we have our SVG, we have to still convert it to this Android vector drawable format. So there is a few ways of doing that. The first one is the built-in Android Studio tool, which is called the Android Studio Vector Drawable Import or something like that. So we use that for most of our graphics, and it worked pretty well. Sometimes we had some problems with some SVGs. So there is a second tool as well, which we tried out, and it helped us out in some of these situations. It's called InLoop SVG to Android. It's an online tool. So for your case, like, just try out both. I mean, this Android Studio import works fine in most of the cases, but if you have some trouble, then you can try out this one. Now going back to migrating from, this image, which is like PNG in this case, to SVG. So the tool that I want to introduce to you is called POTrace, and actually takes as an input a bitmap, which is like, if you have a PNG, you can easily convert it to a bitmap, so that's no problem. And then just run a simple command here, as you can see, and there is your output. So there is this SVG file on the right side. So now a quick comparison here. As you can see, it works pretty well. There are some stuff that you probably would have to fix yourself using like a graphics editor, but in most cases it worked fine for us. So even though we had to edit some stuff sometimes, but like in general it worked fine. So yeah, definitely try out POTrace if you have like a bunch of PNGs that you want to transfer into vector drawables. So now another benefit of using vector drawables is actually the ability to use animated vector drawables. So on the right side you can see a screen, and this is a screen from our app, and this is a login screen where we have like this animation here. So normally, if you didn't have the support for animated vector drawables, you would normally store this animation, which has probably like around 30 frames, let's say, per second, as separate frames, as separate PNGs, and you have to pack it all up in your APK, and of course, like, it all takes space, right? So fortunately, you don't have to do this, because this format just allows you, to like save that space by just getting rid of all these PNGs. So that's another benefit here. Now issues. Yeah, there were some issues, not too many though. One funny one that I want to share with you is, as you can see, like this Visa card on the right side there. There is this this Visa label, and every second time you enter the screen, for some reason, there is padding around it, and sometimes there is not. So we kind of didn't know why it happened. It just happened on API 21, so just on Lollipop for some reason. We kind of like found a workaround around it, like for this case. But yeah, it was just kind of funny. But still, I mean, that's just like one minor issue in comparison to all the benefits they get from switching to vector drawables. So don't make that stop you from, converting. Now, what else could we do except for switching to vector drawables? So another thought would be maybe to just reuse your graphics. So first off, we have this example here. So we have this wave icon that we have in our app, and we use it in like 5 different contexts, 5 different configurations. And so normally we have to store it as 5 different PNG files, possibly. But, well, because we have like, it could be, for instance, blue or green here, as you can see, or, white. So normally we have to like store 5 separate PNG files. But what you can actually do is just apply a color filter on one PNG, or just one, that's actually a vector even. So yeah, just apply a color filter, it's like normally black, and then you get all these for free. So that's one nice thing that you could do to save some extra space, and just it's a lot easier to manage your graphics like that. The second thing that you could do is just apply a transformation. So one of the easier transformations is just rotating. So for instance, you have this arrow here, and like for me, it's like an internal signal. Like whenever I see an arrow in my app, and I know I'm gonna like need to use this arrow in a different component somewhere else, like this one, I'm just thinking like, could I maybe wrap it with like rotate drawable? Maybe could it work? And in most cases, it actually might. So if you have one of these cases, just go ahead and save yourself like some more space in that way. So yeah, just applying all these transformations, switching to vector drawables. We got from 22 megabytes, which we had after applying all these large assets optimizations, and we ended up with 20 megabytes. So it's about 9% reduction here. And it might seem like it's not a lot in comparison to all these 30 megabytes gains that we got from all these large assets. But the hidden benefit here is that we started with this thing, which is about 900 PNG icons, and as you can see, like that's one folder. That's just XXX HDPI. And as you probably know, like you're gonna have it's gonna be multiplied by 5. It's not 900 for all, but you can see like what's the state of that here. So we got from there to this one, which is about 310 PNG icons, so a lot less. And we have vector drawables. So you might still can wonder like why we still have some icons there. Well, there are some limitations of the Android vector drawable format. So for instance, if you have icons that have gradients, then you can't just convert them easily to this Android vector drawable format yet. But for other icons, you can. So yeah, that's what we kind of did. And a nice thing here is that these vector drawables on the right side, as you can see, they are just in one folder. They're density independent. So it's a lot easier to manage your icons like this. And of course, except for we're still saving space. So we're just achieving two things at the same time. And so that's what we did to our icons. And before that, we did large graphics. And I'm going to let Mateusz tell you something more that we did in our app.
Of course. Okay, so the next part in reducing APK size might seem quite obvious. Is just to answer the question what is actually unused in our APK. And we are thinking about unused things. You might probably, the first thought you might have is just to run PROGART and we are done, right? And that's a absolutely valid thought, but unfortunately what valid cares about is only your code. Like what it does, it just do some tree shaking and looks which code paths are unreachable, and can just remove this code from your APK, from your final APK. And it's usually very efficient in it, but unfortunately it doesn't care about your resources at all. So we have a lint check, of course, which has a built-in unused resources checker, which is by default enabled on a warn level. You can increase this level to just failure build if someone puts anything in your repo which is unused in the APK. But what if you ignore that report, or what if you depend on some third-party library which provides their own assets? And maybe we could do some more thing here and shrink our resources, right? And thankfully there is such a tool. It's been in a Gradle toolchain. It's been into the Gradle toolchain for a while now, and all you have to do is to just turn this shrink resources flag to true. The important thing is that you have to combine this flag with the minify enabled true, which just enables the code shrinking as well by PROGART or by the built-in shrinker. And it has to work that way, one after another, because there might be some code which uses resources, but the code itself is not used, so it has to be removed first, and then those resources can be removed easily as well. So enabling this flag and going back to our report, we have our bleak icon, which seems to be unused. So we are expecting that it will be just removed, and surprisingly, it's not removed. I've heard that it's because of some backward compatibility issues on some devices, but drawables which are not used are by default transformed by the shrinker to a 1:1 pixel image, which is a black pixel and takes only 70 bytes, but it's still there actually. There were some problems with APKs which have IDs for drawables generated in the R file, but the drawables weren't actually in the APK. So that's because the shrinker works that way. The second thing about the resource shrinking is, what if you actually doing some runtime lookup in the resources, like we do here. We have an exchange rates. You can see those flags of different countries, and those flags are just loaded in a way like we have a string, and the string is concatenated with some value taken from the server side, and then we are looking up our resources to just find out the name of the flag and load it. And what if we do that way, right? And it seems like Shrinker is quite clever about that. It scans during the shrinking process, it scans our code for the resources that get identifier method usage. If it finds one, it turns itself into the so-called safe mode, which just basically means that any resource which name matches the string which we were concatenating with, then this resource won't be removed, right? So actually it worked pretty well. We just turned our shrinker on. We didn't have to do anything else, and it worked. Of course, there are some ways to manually to manually configure the shrinker to keep some resources or discard some resources, but we didn't have to do that in this particular case. So we had a 20 megabytes APK, and we enabled our shrinker, and we gained another 1 meg of file. 1 meg of benefit in the APK size. So that is 5% of reduction. Then we start digging deeper, and we found out that there is a quite mysterious file called resources.arsc. It's a file which, in our case, just took around 2.5 megabytes of row size and only 250k kilobytes in the download size. So it seems like it is it's being compressed in a quite efficient way. And what this file is, it actually contains all the identifiers, all the mappings between the identifiers and values in your values folder. So it contains, for instance, all the strings you have. And we start looking what this file actually contains, what strings we have in our APK. And it occurred that even if you do not using some languages, but you do use support library or Google Play, they provide you their own components. These components have some labels. Those labels use some strings, and those strings are actually translated into the many different languages you probably don't want to support. And like in this case, we have some Arabic language, we have Japanese and stuff like that. And in our case, ECO is by design published only for the Polish market here, and we officially support only Polish and English language, and maybe we can just drop these languages and gain some other benefit, right? So we can, and it seems like it's pretty easy to do, because we can turn from this to this by only setting risk config values in our default config in build Gradle. So setting PL and N just removed. Let shrinker to remove any unused resources from the libraries which provided the translations. And doing that trick, we slimmed down our app from the 19 megs to 70 megs, so another 2 megabytes of benefit. And what's the most important here is the fact that it's not something tightly coupled to the Eco app, right? It's something what you can gain if your app is not published to the whole market all over the world, right? You can just specify your REST configs, and all the different configurations will be just removed, right? Okay, so that was another 10% of reduction. And that led us to today. So let Jacek talk a little bit where we are today and what are our future plans.
All right, so as you can see here on this screen, we started off with 62 megabytes of raw file size, and we ended up with about 16.5, which is 73% reduction on size, which seems like it's pretty amazing, right? Like in comparison, like we really didn't lose too much quality on these images, but for users, it's quite amazing. And now we're thinking, like, after doing all of that, we started thinking, like, what else could we do possibly in the future if we needed like some layer, like some next steps for us, for instance. So we took a look at APK split, which is something that definitely is a nice follow-up for what we actually have done. So as you may know, like normally whenever you build an APK, you end up with like a single APK file, which consists of like different folders for different densities. Or like whenever, for instance, you target different architectures and you have some native code inside your APK, there's going to be like two SO files inside. So the idea here is quite simple. You just move from one single APK file into multiple APK files, and you just target things just like a single configuration. So like certainly it's a lot smaller here, and you can gain a lot of space and like save users a lot of download megabytes for the users if you do it that way. However, in our case, it wasn't like a quick switch to this stuff because it introduces some overhead, and this overhead is mainly is about having to deal with multiple APKs as artifacts, and then like whenever you want to test something, you have you have 5-6 different APKs. You just have to know like what you tested is actually what you test actually is going to end up like on your user's device. It's just like storing this there is some overhead, but still, I mean, it's a pretty good technique, and definitely take a look at that. If it can probably help you out a lot in your case, maybe. So yeah, now going to our pro tips. The first and most important one is just optimize your graphics. It might seem like a lot of effort at the beginning, since we had to go through like a lot of steps. But I'm gonna make just your user is gonna definitely help. Thank you for that, for not having to download 100 megabytes of app. So yeah, just definitely do this. While doing that, you can pick up any tool you like. There is a lot of tools on the market. We chose PNG Quant, but there is PNG Crusher. There are some other tools. So just choose whichever works for you. Same goes for the different formats. So as we told you about like earlier, there is a WebP format, which is very efficient. If you're targeting APIs like 18 or higher, then definitely try it out first, because from our we kind of tested it and internally, and it seems like it's a lot more efficient than PNG and JPEG. If you can't do it, then stick to and you have to stick to PNG and JPEG. Just try to pick like the format that works best for like for your particular image. So like some images is going to be PNG, some images is going to be JPEGs. So just try it out. In terms of icons, just switch to vector drawables. At this moment, there is pretty much no reason to just stick to PNGs. It's a lot more efficient to do it to keep them as XMLs, and it's going to save you a lot of space. It's going to be a lot easier to maintain. And now, last but not least, start playing with the APK analyzer. So that's how we kind of started for us. It showed us where the problem is with our APK at first, and it's a good starting point for you as well. And now, some stuff worth saying. So first off, there is this guy you probably know, called McAnalyst, and he has a great channel on YouTube, a lot of videos, hashtag perf matters, as well as articles on Medium. So a lot of nice stuff there. So definitely check him out. And J.Karaśkiewicz with his presentation from Google I/O, put your app on diet, as well as a series of articles as well. So definitely good, great names to look up and check what these guys did, because it's amazing stuff. And Wojtek actually inspired us with his talk and his articles to actually go through this whole process and optimize our own app. So yeah, definitely check these guys out. So yeah, that's going to be that from us here. If you have any questions, we're going to try to answer, I hope.
Yeah, we do our best.
We'll do our best. So thanks, guys.
Thank you.
Thank you, guys. We have time for maybe 1 or 2 questions, so if anyone has a question here.
Mike?
Thanks. So one question regarding the resources which are actually embedded in the Android on the phone itself. So I was wondering if you have considered reusing the resources which are actually already on the Android, or they don't really scale for you, because
we actually do that, because for instance, like for checkboxes or radio buttons, the action bar support library just provides you some images which works very well. They are even animated, like Jacek showed us. So yeah, we do that. We just set a proper theme, and we're fine with that, as long as our client does, right? Sometimes there are components which just they have their CI, they need this particular plus or icon or arrow or something to look exactly like on the web, and then we cannot use that. But for the checkboxes, for the radio buttons, we use the native version of which Android provides.
Okay, so my last question is regarding the adoption of the WebP format on the iOS, because usually you provide the application of both major platforms. I wonder how does it work, and
Well, there are some practices, and we think that it's generally a very good idea to share resources between platforms, like having a separated Git repo, and which is actually a submodule of your platform repos. And regarding WebP, we didn't we didn't do any checks about that, but just a sample Googling led me to a conclusion that there is a library which can render WebP on iOS. I didn't use that, we didn't use that in our team, but we will definitely give it a try.
Okay, thanks.
Okay. Thank you very much for your questions. Thank you for the great talk.